Okay, calculus students, this is the local linearity video. Number one, it says on your calculator, graph f of x equals x squared. So go to y equals, and you're going to hit the x button, which is up here. And then a shortcut for x squared is over here. If I hit a square, it adds the exponent of 2 to anything I've just typed in. So now I have y equals x squared. I'm going to hit graph. Ooh, that doesn't look like the graph of y equals x squared. Important thing to remember on your calculator is if your graph is ever messed up, you need to hit zoom 6. And that takes it back to the standard view. So I realize you can't see my screen perfectly, if at all, but trust me now, I have a perfect looking parabola. And question 1 on your worksheet says to sketch the graph below. So pause and sketch the graph. Okay, number 2. It says to zoom in on a specific part of the curve, that is x equals 3. I recommend you hit pause and try to follow the written directions now, and I'll talk you through it when you're done. So here's how you zoom in on x equals 3. You're going to hit the trace button, and a cursor will appear. You're going to hit the left or the right arrow and move up along the curve. Down here, what you'll see is x equals various numbers. And if I'm looking down at the bottom here, I see x equals 2.55, x equals 2.97. I'm close to 3. Then I hit the button again, I get x equals 3.19. So I'm not able to land exactly on 3, but I want to. So here's where a really popular zoom feature comes in. It's zoom 8, which is zoom integer. So I hit the zoom button, and then if you scroll down, you can see number 8 says z integer. So I'm going to hit 8, and then you have to hit enter on this one. I hit enter. It changes my parabola, right? But now if I hit trace again, you'll see that it landed right on x equals 3. If I hit the right arrow, it's x equals 4. Then x equals 5. Hit it again, x equals 6. So now it's going to allow me to zoom in on the integers. So let's move, so we get back to x equals 3. And here's my cursor flashing, and down in this corner it says x equals 3. And now I want to zoom in. So I hit zoom 2 for zoom in. So I'm going to hit 2, and you have to hit enter. Oh, and now I'm closer. My cursor is still on x equals 3. I want you to do it one more time. That's what the directions say. So I'm going to hit zoom 2 and enter again. And now I'm zoomed way in. And it says, sketch what you see. Explain why this looks like a line and not a parabola. Is it really a line? And how do you know? And then hit pause and come back when you're done. So number 3 says, what do you estimate the slope of that line to be? So here's the line that I have on my calculator screen. In fact, the line on my calculator screen is probably a little steeper. And do you remember that slope is just rise over run? It's actually a ratio of rise to run. So I'm going to pick 2 arbitrary points. And it's nice if you use a straight edge on this. So I'm just going to go straight up and straight over. And so the rise to run ratio, let's see. There's my run. If I kind of trace it down here, how many of those fit? So how many, I have 1 run. How many rises do I have? 1, 2, 3, 4, 5. A little more than 5. So I have somewhere between 5 and 6. So I can estimate that slope to be 5 or 6. See how I did that? I did the ratio of the rise to the run. Okay? Also, you can think of that as the change in x. The change in y over the change in x. I kind of botched that. There you go. Change in y over change in x. Okay, so approximately 5 or 6 y's for 1 change in x. So let's do number 4. Calculate the slope of this part of the curve. You may use a calculator, but show the numbers you're using and the slope formula you're using. So you remember slope could be y2 minus y1 over x2 minus x1. But that is so algebra 2, right? That's so sophomore year. Let's use something more calculus-like. Instead of y2, let's say f of b. Instead of y1, let's say f of a. Instead of x2 minus x1, let's say b minus a. Okay, so if you remember from the other video, the a value is the value, the first x values. So so a is going to equal 3. So this will be f of 3. And b is going to be the second value. Oh, what are we going to use for our second value if we're going to find slope? Well, why don't we hit trace again and go one notch up the line. Okay, so let's see. For my b, I can use, my calculator showed x equals 3.0625. So see what I did? I used, for a, I used x equals 3. Now I need another x value. I just moved over a little bit, and the next x value the calculator gave me was 3.0625. So f of 3.0625. And so b minus a, we just said what b was. 3.0625 minus a is 3. So there's my change in y over my change in x. But do we know the values of this? What is the y value that goes with 3.0625? Well, I can just look here. It says x equals 3.0625. Y equals 9 point. And I'm going to have you copy all these decimal places for now. 89063. Usually in calculus we don't need them all, but for this we do. Minus f of 3. We can go back and see when x is 3, y is 9. That makes sense because remember that y equals x squared. So that makes sense. And then a minus b, we can still keep that. 3.0, or b minus a, 625 minus 3. So now I filled in all the numbers. F of b minus f of a over b minus a. Okay, and let's calculate this. So I'm going to do second quit. I'm going to use some parentheses here. So parentheses, 9.3789063 minus 9. Close parentheses. Now I need divided for the fraction line. Parentheses again, 3.0625 minus 3. And I hit enter and I should get my slope. Hey, my slope is 6.0625. We can just stop there. I think that'll be okay. Or you can put the 08 if you wanted. So box that answer. That's your slope. Hey, that was pretty close to what we estimated too. I said between 5 and 6. And ended up being a little more than 6. So let's look at number 5. So 5 said, write the slope equation you just used, but use the other formula. So remember, want to know what a was. Well, for a, we decided to use 3. What was the change in x? Is it the change in x just however much x changes? So here I have x equals 3, and then here I have x equals 3.0625. So you could say that the change in x is b minus a. So that would be 3.0625 minus 3. You could probably do that one in your head. So the change in x equals 0.0625. Okay, that's how much x changed from our first point to our second point. And then we need to know a plus delta x. Do you remember that that's the same as b? But we can do it. What's a plus delta x? Well, it's 3.0625. Took us right back to b, didn't it? Okay, so we have the 3 things we need now. We have this one. Probably wrote that on your paper. We have this. We have delta x. So now we're ready to use the Cooler formula. Pause the video here and try to do it yourself. And remember, instead of b minus a on the bottom, let's just say delta x, because we're cool like that. Okay, what is a plus delta x? Well, we just figured it out a minute ago. Should be on your paper, 3.0625. What's f of a? That's just f of 3. Delta x, 0.0625. Now we could look at the graph again and get the y value that goes with 3.0625. But let's do it the other way. Do you remember that the graph that we're working with here is y equals x squared, or f of x equals x squared? So let's do it that way. So f of 3.0625 is actually 3.0625 squared, right? Because f of x is x squared. Minus 3 squared all over. Do we square the bottom? No, it's just the change in x, 0.0625. So let's put this in our calculator. So I'm going to hit second quit to get out of the graph. I'm going to need double parentheses here. So the first set of parentheses is for my whole numerator, and then I'm going to parenthesize this. So I get another parentheses, 3.0625 parentheses. I could use this little triangle squared, but I like hitting this x squared button. It raises anything to the second power. Minus 3 squared, let's just put minus 9. Close the big parentheses, divided by numerator, denominator, 0.0625. Enter. And there's my answer. 6.0625. It's almost exactly like our last answer. Okay, so it's good that we got the same thing. Okay, one more way to do this. The super cool calculus way. This is the almost cool calculus way. The real grown-up calculus way is coming at you right now. What we're going to do is, instead of writing an A, from now on, we're going to write X. Just plain old X. That makes sense, right? So instead of saying f of A, let's just call it f of X. That's what it is. And then instead of saying instead of saying delta X, we're going to use H. Because what's going to happen later is kids don't like having x and delta x in the same equation. So most calculus students substitute delta x with h. Personally, I think delta x is cooler, but I don't want to mess you up. So our new equation, instead of f of a plus delta x, right, a plus delta x, we have f of x plus h. Same thing. We used to have minus f of a, now we have minus f of x. Over, instead of delta x, we'll have h. So now let's fill this in again, just like we've been doing. What is, oh, you were supposed to write what x is. That was a, that was 3. What's the change in x? 0.0625. And then you are ready to fill in and get your answer once again. And this video is done. You should be good to go for the rest of the worksheet. Please do your best on every question and bring any questions to class.